Okay, so let us get started. Just a quick revision of what we did yesterday. So yesterday we created a sample C program just to understand how the programs work on um, all the devices that the programs are running. So what is the difference between interpreted language and um, the compiled language, and how does Python look slightly different from C? So you can see that we haven't defined any data types for each of these variables, whereas in C you have defined what type of um, data type it is for the variables. So when we say data type, that means just imagine like a large theater where or a class where you have like rows and columns of chairs, and you are asking for certain number of seats. So integer would take n number of bytes in, yeah, it's 32 bits, then which is 4 bytes, and then so on. Like you don't have to remember that, but remember that each of these data types have different requirements of the memory. So this memory, why we need to do this is because we are going to ask compiler to allocate memory on the RAM, and then so that the CPU can read those um, memory chunks, and then it knows, okay, for the next instruction I have to read 32 bits or something like that. Okay, so yeah, so now you can also see that the ID, when you open it in ID, it looks different, and there is like syntax highlighting and so on. So it is easy to read, right? That is why people use ID, and then you can also see what are your files, project files, and you can create folders and multiple files and so on. Okay, so that is what we studied yesterday, and there were some um, exercises that were given, so you can fiddle with that. So whenever you see square brackets, it's a list. Python interprets as a list. And then whenever you see round braces, which is like this coordinates, this line number 21, um, Python interprets as it as a tuple or a tuple. So dictionary is nothing but key and value. Sets are similar to dictionaries, but it does not have any value, just the keys. The use case is what we discussed. Like you don't want in your program at some point of time you want to create something which has only unique values, does not contain any duplicates. So yesterday we also discussed um, an analogy to deduplicate or remove duplicates from a column in Excel sheet. So it's similar to that. And so there are a couple of basic functions in Python. So yesterday we saw dir, and also day before yesterday we looked at type of function, which gives us a little bit information about the objects inside the. So all the variables, functions, everything is in Python is object. We will see what is an object and what is object-oriented programming in next week. But just remember that all the things that we do in Python is object. Okay. And object has attributes and some functions. Yesterday we saw, we looked at set and list. We saw some functions, right? Like set had just, so in the set you cannot modify any of this. Sorry, in tuple you cannot modify any of the values, and in set you can do like add and remove and so on. In list you can do pop, push, and so on. So you can read the docs, so you don't have to write anything. But yesterday's class, yesterday's exercise, what I was expecting is to like fiddle with your data types and understand how it works and print the values, like add a value, remove a value, and try to modify a certain value and things like that. Okay, so I hope you have done that. If you haven't done that, then that, please try to do that today, so that you can move faster in coming classes. Okay, so I'll just uh, go back to what we're going to study today. Okay. So yesterday we looked at these parts, right? So I'll just explain mixed data types, conditionals, and functions. This is fairly simple constructs because we do this as humans. We do this every day, like iteration and conditions. So I'll just show you how it is done and how do we translate that in terms of or translate that in programming context. Okay, so what do we mean by mixed data types? So yesterday we looked at list, right? So list is nothing but it looks like it has a square bracket, and you can put any number of values like one. You can put a string like hi, and so on. So this is a list, and you can also create list of list, which is nothing but you can have list, and you can also have list inside a list. So this type of mixing the data types is called as mixed data types. So where it is used, yeah, for example, you want to parse a file, and you want to parse a file which is in a structured manner. For example, you might have seen XML files, JSON files, even Excel sheets. So if you look at Excel sheets, probably if you read that, what you want to um, catch hold of is rows and columns, right? So rows and columns can be expressed as some nodes in XMLs, and even you can represent in JSON. We'll come to that, what a JSON means and what XML means, etc. But you can represent a file in a structured manner. So, for example, say like let us say some structured example, say parts of the car. Okay, parts of car. So if you want to like just write a note, right, on your notepad, what would you do is okay, this is car, and car has like steering and say wheels and so on. Okay, um, so and then under the steering, you also have like smaller parts like horn, that navigation buttons, whatever. Okay, buttons. And wheels has like other like screws, nuts and bolts, tire, rubber, and all these things, right? Tire, so on. So this is how we imagine or envision the car as humans. Like any given thing, we have a context, we have a bigger object, and then we have smaller objects which is inside this uh, thing, and then uh, we create a structure in our mind. For example, if I say nuts and bolts, you imagine nuts and bolts, but you don't know what it is. So if I say car, nut and bolts, then your entire world is going to narrow down to limited to car. And then if I say it's tires, nuts and bolts, then again you can narrow down from the entire car to particular part, which is tire. So that is where you have structured information that like how we process. So it can also be expressed on computer files, so that those are called as structured text. So there are some formats. Okay, so we'll come to that. So when we if you try to put that in terms of data types that we have studied, so what would you do is probably you can take, say, I will define car, or and then this is just for example. This may not be the perfect one, so I'll just define the car, and within the car, I'll say or car parts, something like that. Car parts, steering, and then wheel, and so on. Okay. And then within this steering, so in this variable, it can be variable, or you can also directly put the values. So I can put a list of subparts. So steering parts, something like this, and then you can put like or like yeah, buttons and so on. Okay. Similarly, like you can do wheels. And so once you have this, you will have list of lists. So if you just imagine without any variables, it will be like list, and then there are multiple lists. Okay. So this is how we organize the information in terms of data types. So this why this is important, because now we are trying to translate the real world objects into the programming. So if you can imagine, you can express in programming context, and then you can operate on it. So what are the operations that we do on these data types, and what do you mean by logic and things like that, right? So uh, we humans always would make decisions, right? So how do you make decisions? For example, say at um, 7 o'clock, I want to attend class, Python class. Okay, so this is my like goal of the day, like one of the activities. Okay, so what we do is, say for example, you get up at like 5:30 or 6 o'clock, whatever. So and then you look at the time, and then probably you go back to sleep, and then say look at look at the time, and then say go back to sleep, and then if it's 6 o'clock, something like that, go for a walk, something like that. Okay, and so on until you reach 7 o'clock. You don't log into Zoom, right? Zoom login. So what are we trying to do as humans? If you try to, so the decision making and the learning, all the context setting, it happens so fast for us as humans. We For us it will be to break it down to small um, decisions or small actions. It takes a process. It takes time to like understand what we are thinking. So if you try to break down, so if I want to translate this into, say, a programming context, so let us write a pseudocode. Pseudocode is nothing but like it is not specific to Python or any language. It's just a like you can write a note. Okay, so if I want to write, if um, current time is say is not equal to 7, then don't log into Zoom. Don't log in. Else, else Zoom log in. So this is how we make decisions, right? This is like if this is called as if else condition in terms of programming. Okay. So and there is also something called as else if elif. I'll come to that. So and then say else do this, and so this is anyways comparing numbers, but you can have for example multiple conditions. You can also have something like if it is 7 o'clock and um, it is a weekday, only then you do uh, log into Zoom, or else you just don't log in. Okay? Something like that. So you can have any number of if conditions. Like you can have this sort of a elif, else if. So else if is called as I think else if or elif. So there are different languages that use different. You will look at the Python, but yeah. So else if. So just understand this is both are same, else if, and then finally you do else. So these are the conditions. So list of conditions and then do something. You can have, of course, any number of if conditions. You can also do if this and so on, and also you can do a nesting of if else condition. So what do I mean by nesting of if else condition is like you can also express, say, if it is um, if 7 o'clock uh, and if weekday uh, Zoom call. Okay, so this condition will you will get into this condition only if this condition is true, right? So, and you can of course keep adding any number of if conditions or if else conditions like this. So this is here called as if else nest of if else condition. So this is nested. So nested conditions. You can call this as nested condition. So why do we need this? Because decision making or the when you express in programming context, what happens is you break down the problems into smaller parts, and you see there are so many decision making to reach or to execute one statement. It could be function, it could be anything. Okay, so that is where your if else conditions comes into picture. Okay, and when does the if get executed? So when this condition is true, right? uh, and you can also express it in a negative sense, in the sense that if 7 o'clock, you can also mention that if the current time is greater than 6:59, something like that. You can also say that greater than or equal to 7 o'clock. So you can express same thing in a different ways, but yeah, we will look at all these things. But yeah, so you can express in different ways, but the overall idea is this expression should be true. So if it's false, it won't execute this at all. Okay. So if it's not 7 o'clock, so this entire block won't be executed at all. And then it is not necessary that if there is a if, you need to have else condition. It's not necessary. So, but else needs an if condition, right? Because obviously it's like if it's not this, if do this. So that is the binding factor. So yeah, we will look at that, and small note about loops. And what are these loops? What do you mean by loops? So so imagine so if you have what do you call a piggy box, right? Piggy box which has like you have collected coins inside the piggy box. Okay, something like this, where we used to collect money, right? When we were kids. So when there was no UPI. So you collect money like coins, and then one day you break it. And when you break it, so it is broken, and then the coins are here. So if you do the exercise of counting, so of course we humans are like very fast. Like we look at like okay, look at this, and then we just count it very fast, right? Okay, once and 2 rupee coins and 5 rupee coins and so on, and we group it and we calculate it very quickly. So if you want to break that down in terms of programming, how does it look? So we as humans, we are looking at coins, and our input is being processed through our eyes, right? And we know that okay, we recognize the coin, and then we segregate the coin which is counted, which is like we keep that coin aside, that is which is already counted, and then which is not counted, we like bring it um, to the other side, and then we increment a number. For example, just for the sake of simplicity, let us just consider these are all 1 rupee coins. And As humans, what we do is counted and unaccounted. So let us say counted and uncounted, right? So initially, all the coins. Say let us consider like just 5 coins. One, two, three, four, five. 5 coins of 1 rupee coins are here. The first step is like to break the box, right? And then the second step would be to count this. So when we start counting this, we move this coin. So we have 4 coins here and we move here. And what do we do? We have like bookkeeping. So you, if you have a notepad or like somewhere on your mobile, probably you'll take down that, okay, I have one, or probably you can. So like in primary schools, we do this, right? Like we count like this. So I have 1 coin, and then in the next step, I have like 2 coins, 3 coins remaining here, and then I'll add here, and then until you get like 4, and then last one we cross that, which means this pattern is makes it a file, right? So this is what we do as humans. So what we are trying to do, let us even further let us further break this down, and so let us put that in programming context. So now, since you have you are seeing the coins and counting, it is easy. So now, if I ask you to count blindfolded, so if you imagine that you cannot see the coins, then how will you count? So you will do the same exercise step by step. You break the this one, and then you use your fingers because you need to like sense, right? Use the fingers and do the same thing. So just imagine that you have like a finger like this, and then you push this coin from here to here, right? And then you mark probably somewhere uh, in the notepad or somewhere, and then you probably memorize or whatever, and then you move 2 coins and so on. So if you want to write it in terms of programming, what I'm trying to do is I'll just write pseudocode. So I'll have a condition, say until um, until you have no coins left. So if this is called as pseudocode, and also pseudocode is used to express the steps. So this is called as an algorithm. So don't get intimidated or be afraid when people talk about algorithms. Algorithms are nothing but breakdown of the steps. Okay. Okay. So this is the first step, or probably this is a condition, right? Until no coins left, what do we do? So first step, probably use your like use the finger, move 1 coin other side. So moving 1 coin other side is uh, is an execution piece, right? Like exec execute what instruction? Move the coin. Move to counted, and you also have one more step to execute. Keep track, right? Or keep tracking. Keeping track is nothing but incrementing the number or by 1. So if you have 1 rupee and then you have 2 rupees, then you do 1 plus 1, right? So increment. Okay. And then what happens? You continue to keep doing this until um, there are no coins left. So if you start from here, so if you have a small kid who can do this exercise, you can tell him or her saying that, okay, until no coins left, okay, you are blindfolded, try to count the numbers. So what he's using is he's using his finger to count the numbers, and he knows that there's the first coin. So at his hands or at his fingers, initially there are no coins at all. So if I just say finger is called as I, like if you want to put it in terms of variable, initially it is I is equal to 0. Okay. And then this condition is beginning condition, right? And then what do you do? So until no coins left. Okay. So you can also put a condition that I is greater than or equal to something, some number. Okay. So here it's probably a condition. I can say, since you, okay, I can say until no coins left. Okay. So let us come back to here. And then you can also have a, an execution in this for this I. You can also say that I is equal to something, and this is the beginning condition, and this is the ending condition, right? So beginning condition and ending condition. So what do you do in between? So you're also like trying to move your finger, right? So uh, if your finger is here, and then your finger moves towards this side, right? So this is called as like incrementing. What are you incrementing? You're incrementing, like you're moving your finger, which is nothing but, you can also alternatively like move the coins towards you, but that is what is that is what happens in programming. You can also have I is equal to I plus 1. So in this case, it is like I plus 1 because you are moving your finger one step at a time. So this forms a basic condition for any loop. Any loop has these conditions. What are the conditions? Beginning conditions, beginning condition, ending condition, and there is a movement condition. So I think I forgot the terminology, but yeah. So do some execution or something like that. Execute something. Okay. And then if you want to put it in terms of programming, you can put something like for I is equal to 0, which is like your fingers has nothing, so it's at a 0 position. And do say I is equal to I, something like incrementing. So this is in typical languages like C, C++ or Java. So this is called as an incremental operation. This is nothing but I is equal to I plus. Until what? I is lesser than, say, I can give some number for just for now. So just say that it is not more than 20 or something like that. Okay. And then you do your count, you do your logic. What was our logic? So let us look at this part. Our logic was to move our coin to some place. So I can say a function move coin to counted or something like that. So counted bucket or something, counted bucket or something like that. Maybe it's a function. So internal implementation, you don't have to worry about that because you're just writing down, and then you can get into internal implementation. And then you're not just moving, you're also counting it, right? So you're incrementing. So probably I have some variable. I will have count is equal to the current value of the count plus 1. So this is what we are trying to do in this exercise. Okay, so this is what is called as loops. So there are two ways to do loops in any programming language. One is called as while loop, another is called as for loop. So we'll look at the syntax. No, it's not a problem, but yeah. So this is what a loop look like in any programming language, and where have we derived from? It is derived from our like usual thought process. All the programming that we do is a translation or breakdown of what we are already doing, what we are already experiencing. So that experience is written into the logic of the program, and then we simulate the real world problems. For example, this was a problem where I had a box of coins, and then I'm counting it. So this is just counting. So you can also do like lot of other actions. For example, you want to like look at you want to sum up all the numbers in a text pad, like 3000, 4000, whatever, and then you read a file, and then you collect all these numbers into, say, a list, and then you can iterate through the list, and then you can do that. So this is how, like, there are, like, you can have a lot of examples, but yeah, these are the this is what a loop does. So let us get back to our editor and now understand uh, what how the loop is implemented in Python. Okay, so we will go back to this. Okay, so I'll ask. Let me get rid of this drawing. Okay, so I hope you have started using Copilot, and okay, I'm going to ask Copilot because now you have understood what is a loop and how a loop is expressed in programming. You can simply ask, um, I want to learn about um, loops in Python. Okay. Now, I'm going to create a new file so that, okay. So I'm going to take this snippet and just put it here and try to understand what it is. Okay. How do I increase the font? I hope it is visible. Okay. Now, whatever we have studied, let us try to okay. Let us try to execute it first, so that we. So either you can execute it like this. You can see that it has opened a terminal. So this is not done by Copilot. This is done by the editor. So if you press this button, which is like execute on any given file, it will take it will invoke the binary, which is like Python 3, which executes this particular program. So it already knows because of the settings when you install Python and when you install VS Code. So the settings are already there. So it will ask for where should I find the Python binary, and then you can point it to there. So it also automatically detects it. So this is the command. This command is nothing but what we did yesterday on the terminal. So same folder is here. So you can look here. It's the same folder. Okay. So you can also do Python 3. What was the file name? Loops. And then this is the print apple, banana, and cherry. So where are these fruits in the program? So here is where it is. So if you look at square brackets, it is nothing but a list, right? So how do you iterate through the list? So this is how we iterate through the list. Now you might be asking a question, like, okay, you told us that there is initial condition. Where is the initial condition here, and where is the ending condition here, and like, what is happening? Okay, so why is this? Does this look like this? But actually, it should look something like for I is equal to 0, and then I until something, and then until the last fruit, which is like, there are three fruits here. You can do like n is equal to 3 until last fruit, and print something like that. Okay. So why are these conditions not there in Python? So as we were discussing yesterday, so every data type is like anything in Python um, a is an object, and each of this object has functions which can be used to, you know to operate on that particular um, data type. For example, in list, if you just look at, I'm going to open the terminal here, and then, sorry, Python 3, and then I'm going to paste this copy and paste here. Now I have fruits. You can you have fruits here, and then yesterday we looked at an helper function which is dir. Dir, so everything is an object. Dir gives us the functions and the attributes that are there in any given object. So for example, if I take say book, so book has a lot of attributes, right? Like how big is this, what is the like dimension, what is the color, and how many pages it is, and all these things. These are the attributes. And functions are nothing but you can open the book, you can close the book, you can like flip the pages. So these are the functions on top of a given object. So let us look at what functions and attributes are there in fruits. Fruits is nothing but list. So how do you know it is list? How the Python knows it is list is like this. It looks at the type of this. So it's a list. So for now, just ignore this. We'll come to this. What is this class mean? And yeah, so this is a list. And you can do dir of fruits. You can see that there are several functions here. So for now, you don't have to like worry about this double underscore functions, but just look at the functions which does not have those underscores. Okay, append, clear, copy, count, extend, index, and all these things. So every object has something called as an iterator. So that iteration is done by this internal function. Okay, so which is called as iter. So this is a internal function which will do all of the things that we discussed, which is like initializing the first, it automatically knows that okay, for this to iterate this list, the first element is this, and second element is this, and then I don't and third element is this, and so on. So the incrementing part, which is like for if I had to write, for example, write a simple loop in C. Let us just look at how different it is from Python. Okay. So if you look at this, it has I is equal to 1, I is lesser than equal to 5, and I plus plus, which we discussed. So this is like compared to Python, it is in terms of for loop, it is still sort of a primitive construct, and then it does not have, because there is the it is not an object oriented programming language, and even in C++, you need to write your own iterators. So people have written their own iterators, and then you write libraries on top of it, and then you arrive at this sort of a construct. Okay. So yeah, so internally it already knows. So that is why like learning Python is quite simple than to learn, C, C++, and such languages, because you really need to understand each bit and you cannot assume things. So in Python, you don't have to understand write all this primitive things, loops, and so there are like um, features which are like out of the factory, like it's already there. So these are like common functions which can be operated. So it's already there. Okay. So that iterator will take care of internally forming this sort of expression, and it does that. So how does that know that this is the ending? Like I is I is equal to 1, I is lesser than equal to 5, right? So this is like ending condition, what we discussed in our example. So how does it know it is lesser than or equal to 3? Is because every object, when you create, it has a size. So you can look at like, so there is a function called as length. So which is actually that calls this function internally. Every data type has this internal function. Okay. So for now, consider all these double underscore functions as internal functions. So you can say fruits, and you can say that uh, like and you can pass any data type to this length. It will give us the length of this. So when we create an object, um, we are asking for some number of seats in the row, right? So during that time, it already counts and keeps updates this length. So that is where you sort of reach the ending condition or the terminating condition for a loop. So that is already implemented inside this iter iter function. Where did it go? Here. So you don't have to worry about this. So now this is why Python has this constraint rather than this constraint is because so this is more closer to English, right? Like okay, for this so if you walk into like your wardrobe, you can say that okay, for iterates through like for the in this given wardrobe, okay, there are this number of clothes. I want to pick one of them in there. So it's like just imagine that if you are blindfolded and then you just have to like pick up your jeans, so like some color, some random color, okay, so then you like close your eyes and then you start from the beginning and then you pick up jeans, right? So that exact thing is translated inside the iteration. So you're picking up or you're moving your hand to that particular piece of cloth is what is iteration. Okay, and that is already there in the uh, inbuilt in this. So this is like closer to like human interaction. So this is easy to remember and you don't have to remember the programming concepts. So that is the reason that people even from non-background can easily learn Python and then do things. So this is how a for loop looks. So it can be easily taught saying that okay, the for any given this one, this is how a for loop looks, and you can start writing the program. So if I teach you like this, or if you learn it like that, so you won't have a connection between your real world activity and then you reach to a common construct of a programming which is like pseudocode and then coming to a language specific thing. So if you have these dots and then you can connect, and if something goes wrong you understand that okay, this is why it is failing. Okay, so let us try to execute. Okay, we already executed this. Okay, and okay, so this is about for loop. So you can in fact um, do the same thing for like this. Okay, let us try to. I'll delete this. I'll take this program, and I haven't read through this program. Okay, let's read it together. So because now it is pretty easy, right? Because now we understood like basic construct of the program, which is like a variable, which is like people is a variable here. Initial is variable, and then let us look at this what this function does in a while, and what this does, and so on. Okay, but yeah, just remember that line number 7. It is asking for an input, saying how many people's data do you want to enter, and so on. And this is a loop, and since there is we are not iterating people, but we are adding something to people. So we are not iterating here, but we are trying to iterate n number of times. So which is like, what is this n is we are choosing from an input. Okay, and then we are doing some execution. So this part is execution. So again, there is like name, age, and these things. Okay, and we are adding that to this. So we will execute this, and we will understand what it is doing, so that we understand the for loop in a better way. So I'm going to execute this. Let us execute it here using this. Okay. So you can see here it is asking for how many people's data do you want to enter. I'll just say 2. Okay. So what is happening when I enter 2? Um, and enter the name of the person. So where is it? So where is the instruction pointer now? instruction pointer is nothing but like it has started from line number 1 right here, and then this is when you put a hash in front of anything, it is called as a comment. So yesterday we saw in C language, like this is a comment, like double um, forward slash. So which means that compiler will ignore that line, so it won't do anything. So where is this particular string? Enter the age of Digan. So how does it know that it's Digan? It's because it went here, it picked up this, entered the name of person, and then I did something like which is entering the name, and then you can see that this variable, which is in line number 11, is used here to get an input or to print, and you can get that. Okay, so we'll look at this input function. So input function, so in IDs, if you just hover the mouse here, you will get the definition like how to use that function. So input is an inbuilt function in Python which reads a string from standard input. What is the standard input in our in a context? Standard input is the keyboard, and where are we seeing it? We are seeing it on a monitor. So to see something on a monitor, we are using print, right? So input has implementation where it has internally it has print statement where you can print something and it will wait. So you can also use simply like input, just input, and then it will wait, but you won't know like why it is waiting, right? So you have to mention somewhere that okay, this is why I am waiting. So input waits for input from the external world, which is like external world for a CPU is like peripheral device, which is a keyboard. And then enter the age of Digant. I'm 39 years old. I'll just put that name, and then name of the person too, which is say month, and then age of the probably 40, like something like this. So now you'll look at if you like just um, try to um, connect the dots from the backwards, uh, like looking at this output and connecting these dots. So this print is coming from this loop, which is defined at line number 17. So what is it doing? It is iterating over people. Okay, and you don't have to remember these things like items, and there are multiple you know um, attributes or functions which you can use to iterate. Because if it was like 6 months ago, I would say that you have to remember or you have to at least know what are this, but you're not going to program like without internet and without GPT, because if you start doing that, you'll be like far behind the crowd that is already there, right? So you have to use co-pilots and then write programs, but you should understand what is happening here. So now I hope that you understood the for loop, and you can see also that so this for loop is different, slightly different from this for loop. It has got one variable. It's like you have 10 coins. For one coin is this I, and then you do some processing, like you go to the bookkeeping and increment the number and then come back, and then it goes back to this and then picks up the next number. So range function is a function which generates numbers starting from I think it's zero. Yeah, it produces zero. You can see here documentation. So where is this documentation coming out from? Is this place. So I was just explaining. Every object has attributes, right? So let us just say um, f is equal to 3 or 4. Just for our, I'll use some other data type. 3 and 4. I'll just use set for now. And if I look at f, which is a set, you can see that this also has iter, which means that you can iterate through the set because you want to process that set, right? Get one number or one element out of that set and do some operation. And then, okay, what was I trying to explain? And then you can also, get that particular okay. What is that? Okay, these functions, and you can also see incr. Okay, it knows the length till when it should do, and so on. So what does range function do is like this. If you just want to like experiment and see what these things do, okay, it returns one more function. It is called as an I, uh, okay, I forgot the terminology. Okay, it returns a function and it returns an iterator. And then if you want to like store it uh, in a list, you can also do something like a is equal to range, say n number. So sorry. As you might have seen in C programming, you use these braces like flower brackets to separate the sections of the programming. So, but in Python, you must have already noticed and you must have already take a mental note that for any there are no like braces and to tell that this there is a section which is under this particular statement. So we do it using spaces or tabs. So that is where we get indentation error, which means like you have wrongly indented. So, but when you're using this particular Copilot, so just you don't have to worry about that at all because it will generate the code which is like working code and it won't have any syntax errors. And then if you just print a, you can see that it's this one. So you can also convert a into a list. How do you convert anything to, if it is supported, it will just convert. So numbers that is generated from a range is 0, 1, and 2. We are asking for n number of elements, which is 3. So you have got 3 elements starting from 0, 1, and 2. So that is what is happening in this. So when you don't have a data type to iterate, but you want to do something. So that is, this is an example where you fetch or you take an input from the keyboard and then you store that value. So what happens is this input, whenever it takes any value from the keyboard, by default, it is read as string. So, but I want to interpret that as an integer, right? Because probably I want to increment it when it hits next year after my birthday or whatever it is like. So that to increment a number, you want that particular string to be interpreted as an integer, right? So that is where we use this. So this is also called as data type conversions. Like if you're converting that to a string, for example, I can do say one more variable x is equal to 2. So type of x is integer. Now I can also do s is equal to like convert that to a string. I can say x. So now if you look at s, it is type of string. It is a type of a string, and you can see that when you print a string, you also get this um, single quotes, telling that it's a string. Okay, so this is what is happening. This is a data type conversion, and then we are storing it somewhere. So where are we storing it? We are storing it in this dictionary, right? So dictionary is nothing but a key and value, right? So this is the key. So if you have done exercise that was given yesterday, so this is the key. So how do you add elements to a dictionary, right? New element. So a key is given and a value is given. So this part is done. And what happens to your variable people? So it has these values. So whatever we entered here, right? These values get, this is first element and this is second element. Okay. You can print yourself and see how it looks like. Um, so yeah, now we have two elements in people, and within that, each of this element, we have name and age, which is key and value. And now we are going to iterate through the dictionary. So the for loop also knows how to iterate through the dictionary. So dictionary has two elements, right? So this is how you kind of get key and value. So this is the function which returns um, step by step, like one by one, key and value. So that is how you are getting this. So you just have to understand this. You don't have to like remember this. And you can also, if you, for example, if you don't understand, select this and click this, uh, and then you can say explain explain selected code. Okay. So you can see that here in your chatbot, it, once we have selected, it knows that loops.py file, line number 17 to 18, it is selected. And then I think it also gives no, some chatbot here as well, some editors. I don't know how to enable that, but you can also like, you can just select and like click somewhere here and say explain this. But yeah, anyways, it knows over what to explain. So okay, so you can see that this selected code iterates over a dictionary, and each whatever I explained is the same thing. Okay, uh, and then it does this thing. Output will do so. So this is how you sort of understand the existing code. You write something because now existing code is nothing but the code which is generated. But you need to know how the loops work, how each of the data types has these functions internally built internally, and then how it works, right? So this is how about the loops and nested data types. So I'll also ask this one. Give me example of nested data type and iteration. Okay. So I have done a spelling mistake there. It also autocorrects and it understands that it's a typo. So okay, let us just take this. I'll create a new file called as mixed.py, and I'm going to copy this code here. So now I hope that now the code is becoming familiar. So if we look at this, students, so what are these braces? So these braces could be either one of them. One is it could be dictionary or it could be a set. So since you look at this particular column, which is nothing but it separates key and value. So this is the key and this is the value. So you can see that the entire value of this particular key is a list. That means if you, uh, go back and imagine what we did, it is nothing but we looked at list of lists, right? Car and parts, right? So similarly, we have a dictionary, and within this dictionary, we have a key. Key is always a string. This cannot be or a number as well, but this cannot be something which is mutable. So yesterday we looked at mutable and immutable, right? I think we didn't use the right word, but it's like read only, and you can also write. So what example for mutable is list. That is because you can modify or replace any element, or remove the element from the list. But if you look at tuple, so yesterday we saw that if you try to remove the or modify the existing tuple, it will give an error. which says that this operation is not supported or not supported. Okay. So similarly, so the keys should be not modifiable, because if you can modify the keys, then like the whole idea of having dictionary becomes it doesn't make any sense. Key and value. So either you can have say some element which is like basic data type, which is like say 13 whatever, and you can also have list. So here it's a list. So this is a mixed data type. Why it's called a mixed data type? Because it's list inside the dictionary. You can of course have list inside list. Here you can keep doing as as many levels you want, right? So this is about the data type, mixed data type, and this is how you iterate through them. So I think, yeah, that's should be good enough for today. And I'll just start an introduction to file uh, um, file handling. So in order to do that, I'll just show you where. Okay, example. You uh, give me an example of uh, JSON file. What is a JSON file is J stands for Java, and then I think some object notation. Sorry, J stands for Java, S stands for script, JavaScript object notation. So why it is called as an object notation is because if you just imagine, or yeah, if you just imagine students as one of the elements. So this is a dictionary, right? So this is dictionary if you in terms of Python, and there is a dictionary inside a dictionary, which is a mixed data type, and within that dictionary there is um, key and there is value. So I can take this one, so like make a file students.json, and I'll just copy this file here, and I'll just save this. Uh, okay. So if you want to read this in Python, how would you read that? So because once we say that this is a file, means it is on the like disk, right? That is why we are able to see these parts. So tomorrow we will look at how do we read the file, any file, and how do we read JSON files. So what is a file? So tomorrow we'll look at like what is a file. So when we talk about programming, I have like stressed that you should remember there are three layers. One is your hard disk, or next is your RAM, and then next is your CPU. Okay, this is like basic architecture, right? So basic, any computer would have these parts. So that, but doesn't mean that all the computers will have hard disk. There are several um, devices out there where you don't have like persistent memory or a hard disk. Probably there are sensors and things like that, which are actually having a RAM and CPU, but it does something and sends information, something like that. Okay. So because hard disk is a peripheral disk, so if you look at your old PC box or even now, right? So MacBook, if you want to replace your hard disk, so so if you just imagine those big box CPU boxes, you open the CPU box and then you can insert a new hard disk, right? So it's a peripheral device. You can also change the RAM, and of course, to change the CPU, you have to change the motherboard. Yeah. So these are three things. So whenever we think of executing a program, you should have a mental picture of where is this, whatever we are doing. So where is this file? This file is in like hard disk. So once you execute this using Python 3 says some file, which is say simple.py or something like that. So what happens is our loader in the operating system picks that executable and puts that into RAM. So, but in Python, it has one more additional layer, which is virtual machine of Python, and then that will load it into the RAM. But for all the practical purposes, just imagine that this executable is loaded to RAM, and then CPU starting is executing. So this will bring us to a point where what are the constraints of reading a file? Why don't we keep all the variables in the file? Because there is a latency, or there is some time taken to load the file to your RAM. Okay. So yeah, tomorrow we'll look at the file handling and so on. But yeah, I hope I'll give you some exercises about mixed data types. So don't miss doing that, because once you understand that, you'll connect the dots, like how to read a file and what is actually happening inside that. So spend about like probably 30 minutes or something like that, because you don't have to write a program, right? You just have to like ask your copilot to generate a program and generate a file, and then you say that do this operation or do this, I want mixed data types, and then probably you will go to that particular file and modify one of the elements and print that and see what's happening. So I don't think it will take a lot of time, but spend this time, because now you're what is happening is we are trying to create a mental model of your whatever we are doing, like program. There are variables, there are mixed types, and there are operations that we are doing. So it is getting complicated from our basic data types to mixed data types, and then now we are moving to file, and then we'll also move to like how to process data from internet and so on. So if you do not do this, there will be a missing link. So from here to here, and if you do not do this, so we will move here, and then you won't be able to connect the dots. So all the other things will look or sound gibberish. Okay? So please try to do the exercise that I'm going to give. So I'm trying to make sure that it won't take more than 30 minutes. And I also have explained how to like decompose, or how to learn, or how to generate a program, right? So you generate a program, do something, and then if you don't understand, right click and say that, please explain this to me. Okay. But whole idea is, any program that you write, you should have a mental picture of that, or else you'll get lost. So like what is happening, and you'll do random things and to get something right. Okay. Okay. Yeah. Thank you for your time. And if you have any questions, please feel to reach out. And if you want any one-on-one help, please reach out to me. We can like sit for like 15-20 minutes and solve your problem. Okay. Yeah. Thanks for your time. So, thanks. Bye.